Good morning, my dear students, and a warm welcome to the geography lecture of the 8th standard. My dear students, in the previous lecture, we were studying about the lesson that is the interior of the earth, and while doing so, we had studied about a few layers of the earth, that is the crust and the mantle. Now, my dear students, today we will be starting with the core, and we will see that the core is being divided into two parts, that is the outer core and the inner core. Okay, my dear students, so let's begin with today's lecture. Now, the core starts from around the depth of about 2900 kilometers from the earth's surface. So the core, what is there, my dear students, it starts at around 2900 kilometers. So it starts at the depth of around 2900 kilometers. The part of the earth's interior extending from the mantle up to the center of the earth is the core. So as we have seen over here, just above the core is the mantle. So right from the mantle up to the center of the earth, this innermost part, okay, it is the entire area is called as the core. That is, it starts from the mantle and ends at the center of the earth. Okay, my dear students. Now next, the thickness of the core is about 3471 kilometers. This layer can be divided into outer core and inner core. So the thickness of the core, it starts at around 2900 kilometers, and the thickness of the core, including both the inner as well as the outer core, it is at around 3471 kilometers. Okay, so here again a rough background of the core. It is the central and the innermost part of the earth. Okay, and it comes after the mantle. Right after the mantle, it mainly consists of nickel and iron. I'll be telling you about that later on also. And it is divided into outer core and the inner core. Okay, now next let us continue, okay, with the lithosphere. Now this is a new area what is there. This is very important. The lithosphere is the solid outer part of the earth. So what is lithosphere? It is the solid outer part of the earth. Okay, now this is not there from the textbook, it's just an extra information. Now it is brittle. The above portion is brittle. What do you mean by brittle? That means it can be broken very easily. Okay, it's very weak, it's very light. For example, like the glass. Okay, in your house you have got a glass. Okay, what is made up of glass? That can be broken easily. Okay, whereas steel, iron, they cannot be broken so easily, whereas glass materials can be broken very easily. Okay, now what are the convectional currents? Convection currents, my dear students, now there is the middle mantle flows because of the convection current. So we can see this is flowing because of convection current. Now what is happening is there is hot material which is present. Now when material is hot, it expands itself and become light. For example, water vapor is lighter than water, and water is lighter than ice. Okay, so as you heat up things, it becomes lighter. But what happens when it cools? It again settles down. When it cools, it again settles down. Now what happens? This cycle is repeated over and over again. This heating and again cooling, heating and again cooling. Due to that, there is continuous movement in this kind of a direction, in a circular direction. And this direction, my dear students, is called as the convection currents. Okay, the heating and cooling up continuously of the materials what are present in the earth's interior, this is called as the convectional currents. Okay, now outer core extends from about 2900 kilometers to 5100 kilometers. The secondary waves cannot pass through this core, they get absorbed in this region. This leads to scientists to believe that the core could be in liquid or in semi-solid. Semi-liquid or semi-solid, we can call it as both in nature. Now what do you mean by this? Semi-solid or semi-liquid, my dear students, it is a kind of a material which is neither solid nor liquid. Okay, now I'll give you the example. The best example, for example, is tar. Now what you will mean by tar? Tar means dambar, what you call it in Hindi. Okay, it is neither solid, it is neither liquid, but it is semi-solid. So somewhat it is of that kind of a nature. This area is of that nature. Okay, it is more of liquid, or it is semi-liquid in nature. Okay, not exactly liquid but semi-liquid. Okay, then the waves passed in this layer, the primary waves pass, secondary waves cannot pass. Okay, these both the waves are related with the earthquake. You will be studying in the next year second lesson of yours in your 9th standard about earthquakes. That time you will be having what is secondary waves, what you mean by primary waves. At that time you should remember what I have taught you all now. Okay, but the speed reduces when passing through this layer. The waves are passing, primary waves are passing, but what happens? Their speed is reducing. Why? Because of the semi-liquid nature of the core. The density of the outer core is about 9.8 gram per cubic centimeter. The temperature of the liquid outer core is around 5000 degrees Celsius. So you can see the heat, it's around 5000 degrees Celsius. So you can imagine how hot it is. Now we have learned that the outer core of the Earth's interiors is in liquid state. The proportion of iron in this layer is more. Vertical currents originate in this liquid layer. This is another characteristic of this region. The differences between the temperatures of the outer and the inner core gives rise to vertical currents. The Earth's rotation gives the eddy circular motion. Now what happens? There are two movements over here. First one is eddy circular motion and the other one is vertical motion. Now what is happening? Because of the liquid state, okay, and because of the proportion of iron which is present in this entire core, we can see that there are vertical current which are originating. Vertical is in this way, up and down, okay, up and down. They are originating in this kind of a form. But what is happening at the same time? The Earth's rotation is there. And what is the Earth's rotation? Earth is rotating in a circular way. So there are two different direction waves which are created. The first one is moving in an up and down motion and the other one is moving in a circular motion. Now what happens? Electric currents develop in these spiral eddies. So what happens? These spiral eddies, this round, what is there? There is electric current which is there, which is generating, okay, and liquid iron, and thus magnetic field is generated. You can see over here, due to this there is geomagnetic energy. Now my dear students, you know that our Earth is in slightly tilted position. Tilted means it is bent. This is what it should be, okay, but it is not this. The dotted lines are not the way it's supposed to be, but it is slightly tilted. That is the reason, you know, you might have heard where they say that near the poles it is 6 months darkness and 6 months light. It is because of this tilted nature of the Earth. Okay, in spite of having rotation and revolution, the light cannot pass on this because it is for 6 months in complete darkness, and when it comes over here, 6 months completely in light. Okay, so that depends on which side is the sunlight coming. Okay, is it clear? So due to that, there is this kind of an energy, geomagnetic energy, and this is also called as geodynamo. The magnetic field of the Earth is also function outside the area for quite some distance. So what we can see over here, this geomagnetic energy, it is there around the Earth also for quite some distance. It is not that it is just near the Earth, it is around the Earth also because of this magnetic pole. What we can see, the North Pole and the South Pole. You have studied in science also about this, okay, so you will be having a rough knowledge of it. As a result, a curve develops around the Earth because of the magnetic field. The Earth's atmosphere is protected from the solar winds coming from the sun. So we can see over here, we can see this magnetosphere. So what is this magnetosphere? This is created due to the magnetic field of the Earth. See, here is the Earth, and due to that, these harmful solar winds, what are there coming from the sun, are protected by this magnetosphere. What is there around the Earth? The magnetic field thus develop around the Earth is called as magnetosphere. This is the fifth and the most important sphere of the Earth. So this is one of the fifth and one of the important spheres. Why? Because it is protecting the Earth from these dangerous solar winds. Okay, so is it clear what you mean by magnetosphere and what you mean by magnetic axis? Okay, geomagnetic axis. Now we shall go to the outer core. Okay, the outer core is the third layer of the Earth. We have already seen that it is the only liquid layer and is mainly made up of metals like iron and nickel. It roughly extends from about 2900 where it starts from here, and then it goes up to the inner core, that is to 5100 kilometers. Okay, and it is here which is responsible for the Earth's magnetic field. Okay, so we have seen what to see. This is the Earth and this is the magnetic field of the Earth. The first page also you can see the same image on the cover page. Okay, and due to this you can see that the harmful rays what are there are not coming. The Earth is being protected, okay, from the harmful rays coming from the sun. Okay, the last part, the inner core. Inner core extends from around 5150 kilometers to the depth of the Earth, that is around 6371. So that is the last and the innermost point of the Earth, 6371 kilometers, that is the center of the Earth. It is the core of the earth which is in solid state. So if you see, my dear students, we can see that the core of the earth is in the solid state. The density of this sphere is around 13.3 gram per cubic centimeter. Iron, Fe, okay, that is the name, scientific name of it, and nickel, Ni, is the major elements that are found here. Therefore this layer is also called as knife. So Ni of nickel and Fe of iron gives the name knife. As the materials in this layer are under extreme pressure, the inner core is in the solid state. So my dear students, the inner core is in the solid states. Why? Because of extreme pressure. Okay, because of extreme continuous pressure, it is in the solid state. The temperature here is almost equivalent to the surface of the sun. So imagine it is so hot like the sun, but still it is in solid state, and the reason for being that is it is under extreme pressure. So that's all for y'all in this lesson. Okay, so again over here it's in nickel and iron mainly found, therefore it is also called as the knife. Let us have a quick revision. The earth is made up of several layers. You have seen the cutting of the onion. Okay, in that, like that, there are plenty of layers within the earth. So the outermost is the crust. Crust is classified into oceanic crust, which is made up of sima, and continental crust, which is made up of soil. Okay, then the next layer is highly viscous. Viscous is what? It is highly in liquid form, okay, which can move easily, and that is called as the mantle. Okay, the mantle is the thickest part, which forms about 83% of the volume of the earth. So the thickest and the biggest layer among all the three is the mantle. Okay, my dear students, and the mantle is the thickest. Okay, and then the outermost is called as the outer core, is made up of nickel and iron. It is called as the knife, and the inner core is in solid state because of very high temperature and because of high pressure. That's all for y'all in today's lecture, my dear students. I have completed this entire lesson. This lesson will be coming for y'all in the coming week for the third practice test. So please go through the notes which I have already sent it to y'all. Write it in your notebooks and submit to me by today evening 6 o'clock. All the best, my dear students, for your exams. Take care of yourself, your entire families. Stay home, stay safe. God bless you all.